In this video, we want to dive into advanced Testpoint Check application. This application supports two basic types of testpoint spacing checks: testpoint to testpoint spacing and testpoint to component spacing. We'll focus now on testpoint to component spacing, which allows to check testpoint spacings to component boundaries by taking the component height into account. As you can see here in 3D Canvas, there are components with different heights. It's quite obvious that taller components need a larger spacing compared to smaller components. There are several modes of operation. Let's start with a fixed spacing first and enter and specify a value of, say, 1 mm. The value is a global value to be used for checking independent of the component height. We can specify which outline to be used for checking, place bound or DFA boundary, for example. We can further specify whether we want to measure from test point center or from the test point pad boundary. Furthermore, there's an option to visualize keyboard areas for floor planning purposes. Let's run the check now. As you can see, there are several DRCs. We can now try to fix some of these DRCs. While doing this, for example, using the slide command, the keyboard shapes generated by the application assist us. Let's move on to component height dependent mode and click the radio button Use Rule Set. Let's take a look at the data from default rule set. Data is specified in value pairs. For example, for components with a height between 0 and 3 mm, a spacing of 0.2 mm is required. In the height range from 3 to 5 mm, a spacing of 1 mm is required. You can specify as many value pairs as necessary. Of course, all application defaults, including rule set data, are site customizable. Let's run the check now. Again, DRCs are generated. The keyboard area's oversize now account for the different spacings. For example, the keyboard's oversize from component T1 is much larger than the keyboard area from a capacitor C5, for example. Again, we can now fix DRCs in a similar way like before. Keyboard areas are a great help here. Last but not least, there's a third mode, Match Rule Set by Size. Here, the rule set to be used for a certain test point is derived from its pad size. What does it mean? Each rule set has a size attribute. Default, for example, 0.8 mm, and the rule set large with 1 mm. In this mode, while running the checks, the pad size for the current test point will be calculated first. The rule set whose size attribute matches the current pad size will then be used for checking. For designs with different test point sizes, this mode might be useful.